We are Team CISS from Sri Lanka. Our experiment is about addressing one of the biggest challenges in future lunar missions: growing food on the moon. The moon's surface is covered by regolith, which is dry, dusty, and lacks the nutrients and water that plants need. Without a way to grow food locally, it would be hard to support long-term human missions. So our team decided to find out whether certain crops could grow successfully in simulated lunar regolith and what simple adjustments would make it possible. Our experiment started in a jungle. We were finding for the most suitable plants which would make it possible for us to grow in the harsh soil conditions of the moon.
Hi, my name is Arun Javardhan and I'm from Team CIS and we are from Sri Lanka. I have chosen radish, spinach and green grams as my crops to grow. The reason I've chose those crops are they commonly help to maintain and regulate blood circulation, also reduces the risk of the deformation of heart and helps to maintain the muscle strength and bone strength.
Hi, I'm Julian Preethiviraj and I'm from Team CISS and we are from Sri Lanka. For planting, I have chosen the bush varieties of the plants, butter beans and long beans. I chose them for mainly two reasons. Number one, the ease of growth. Bush beans and long beans are very adaptable and easy to grow. They grow within a short period and they adapt really well to very challenging soil. And also, the second reason, which is it is very healthy for astronauts. It is packed with various nutrients that helps to improve our immunity and which also helps in digestion.
Hi, I'm Sakina Galagama and I have the honor of being member of Team CISS representing Sri Lanka. When it comes to planting the moon, there are several challenges that we must face. It has arid soil, exceeding high pH values, and has 0% nitrogen. So obviously, there's not going to be any growth. To start off with, I added coir and coffee ground. By incorporating coir, it improved soil structure, promotes moisture retention, and neutralizes pH values. Also, by adding the coffee ground, it added nitrogen, which promoted growth of plants. I have deliberately selected the okra plant because it is extremely resilient and compact. We can eat the pods and also we can eat the leaves, which serve as a nutritious salad, which minimizes the waste throughout its lifetime.
I am Supeja Fernando and I'm from Team CISS. We are from Sri Lanka. We are growing crops in lunar soil regolith. I have chosen the seed, our beans, to grow because it has very high nutritional value and as well as it's a legume, the roots fixate nitrogen and the soil becomes more adaptable for other crops.
Good evening, everyone. Right now, we are about to share you all a brief of one of the latest research programs that we are being a part of. First of all, I would like to drive you all through the Artemis mission series conducted by NASA. Artemis missions are aimed to return humans to the moon by 2026 with the final goal of building a reliable and a sustainable presence by the end of the decade. Unfortunately, NASA stopped lunar explorations in 1972 after the Apollo 17 mission due to the lack of funding from the government. But now, over 50 years later, now they are back on the run to go to the moon, and not only that, they are aiming to build a sustainable presence there. Maybe you can call that a moon base. Also, as NASA stated, this mission series will be the foundation for civilization of Mars. This is why this Artemis program series is very important. Artemis 1, launched in 2022, was an unmanned mission, but Artemis 2, which is an upcoming launch, will be a manned mission. Step by step, we are getting close to make a sustainable living on Earth as well as beyond Earth. Now, my friend Supeja will introduce you all the research that we are being a part of. Thank you.
Thank you, Anna. So, I will be talking about the Plant the Moon Challenge. Okay, so imagine trying to grow food in one of the most harshest environments. No water, no air, and soil is nothing like we have on Earth. This is one of the challenges many scientists have to face when growing food in lunar surface. When astronauts plan to go to the moon to live for months maybe, they have to grow their own food. But how do we make plants thrive on lunar surface? For this is where the Plant the Moon Challenge comes in. This global experiment invites students, researchers, and fellow astro enthusiasts to take on the task of growing crops in real lunar simulated soil. An earth-made material designed to replicate moon's regolith. Teams test different fertilizers, soil treatments, and different growth techniques to see what works best. The goal? To find out what perfect conditions to grow plants on the moon and eventually other planets. So as for the 2025 Plant the Moon timeline, the opening symposium was held on January 22nd, and our 8-week growth period will start on February 3rd and will extend up to March 30th. And by April 13th, our final project will be due. So, discoveries made in this challenge not only help the future of space exploration, it also can change the way we grow food right here on Earth. In extreme conditions such as deserts to disaster-prone areas, people could get a great idea of this space agriculture to implement in different ways of farming in our own Earth. So, proving that even the most unlikely places, we can make life possible. To talk about the rest of the presentation, I would pass it over to Fatima. Thank you.
As you humanity prepares for a sustainable presence on the moon, there's still one challenge remaining. How will we grow food in extraterrestrial conditions? This is where the Plant the Moon Challenge plays a vital role in advancing space agriculture. For Project Artemis, this research is crucial. The moon's soil lacks organic matter, has low water retention, and may even be toxic for certain plants. This insight gained from the PMTC experiments helps scientists modify lunar regolith and use fertilizers, microbial treatments, and hydroponic cultures to enhance plant growth in future lunar greenhouses. This is essential not only when it comes to preparing food for astronauts, but also oxygen production, carbon recycling, and ensuring the psychological well-being of long-duration missions. Through the Plant the Moon Challenge, we are not just preparing for lunar exploration, we are growing the future of humanity in space. Now, I pass over controls to Seansa.
Team CISS is excited to embark on an extraordinary journey on the Plant the Moon Challenge, where we will explore one of the most interesting aspects of space science, like growing plants in the moon. Well, with lunar soil simulant, our foundation will be experimenting with key factors that can break or make plant grow: light, temperature, and humidity. These are the conditions astronauts will have to consider when trying to grow food on the moon. And our mission is to find the best way to make it happen. Our background research conducted on local forest areas has given us the valuable insights on how plants respond to different environments. And now we are planning to put the knowledge into the test. By experimenting with variables such as light, temperature, and humidity, we hope to uncover the optimal conditions for the plants to grow in the lunar soil simulant. Every discovery we make brings us closer to the future where astronauts grow their own food, supporting long-term missions on the moon and beyond. This isn't just about surviving, it's about thriving. Our research will not only help future space travelers, but could also pave the way for new solutions for food production here on Earth, especially in extreme or harsh environments. As we work through each experiment, we are not just testing soil and variables. We are testing limits of what's possible. Team CISS is committed to advancing space agriculture, helping to lay foundation for sustainable life on the moon. Our work will play a crucial role in ensuring humans can live and work and grow on the moon for generations to come. I would like to invite Julian for conclusion.
You guys have heard it all. Planting on the moon. What an abstract idea. It's just like fiction. Fiction is not just a story. It's a thing that awaits to be a reality. That means some people may think that this is a dumb idea. But one day, there will come that person who makes that story a reality. So, in such a way, this abstract idea of planting on the moon will one day be a reality, and we are taking the first step in it. This Plant the Moon Challenge isn't just an experiment. It's a bold step that we are taking into the unknown. Because we as Team CISS are testing different variables which are crucial for plant growth. On the moon, not on Earth. The moon is a really harsh environment, and it's really hard to grow plants there, obviously. So alongside with this Artemis mission, we attempt to know what was previously unknown. We want to lay the groundwork for future astronauts, not only to live, but to thrive. And also, once we are done with our research, I'm happy to say that you guys will be able to see what we have done and what we have found.
In our first experiment, we planted our seeds using a mix of lunar simulant and earth soil. We tested different lighting conditions like red, blue and purple lights to encourage germination. However, the plants failed because the soil dried up too quickly. We learned that mixing earth soil with lunar regolith caused the soil to harden and lose moisture very fast. For our second setup, we changed our method. Instead of earth soil, we mixed coconut coir with lunar regolith to help retain water. We planted different seeds, including winged beans, peanuts, spinach, radish, and okra, in large pots. The plants were kept under purple light at night and exposed to natural sunlight during the day. We also added natural fertilizers like coffee, water, and vegetable juices to improve their growth without using artificial chemicals.
As a student and a space science enthusiast, this challenge wasn't just a science experiment for me. It was a chance to touch the future, to contribute to what food systems might look like beyond the Earth. Our mission was to identify plants that could grow in lunar regolith, the moon's dusty, nutrient-poor surface. The moon is not a friendly place for farming. There's no atmosphere, very little water, and the soil known as regolith is harsh. It's dry, dusty, and lacks essential nutrients. Our job was to test whether plants could grow in lunar regolith stimulant using clever techniques and natural supplements. If we can improve the moisture retention of lunar soil and supplement it with natural nutrients, the plants could survive and even thrive on the moon. But we have to keep in our minds that these supplements should be practical and can be available with astronauts on the moon. After much research, I chose to grow two very promising legumes, okra and wing beans. Why these two? Because they're hardy, nutritious, and can be eaten, cooked, or even raw. And they also offer benefits that go far beyond just food. They also generate very little waste. And on the moon, every drop, every leaf, and every gram counts. As I mentioned earlier, the lunar regolith is very harsh. So we must find techniques to keep the water retention. We identified coir, that is coconut fiber, as a solution. Coir offers numerous benefits for plants, including improved water retention, aeration, and soil structure. I mixed coir with lunar regolith in the 2:5 ratio. The next challenge. Lunar regolith doesn't have nitrogen at all. After going through several research papers, I chose coffee water. There are two strong reasons behind my decision. Firstly, coffee water is rich in nitrogen, and coffee is slightly acidic, which can help lower the pH value of the lunar soil. The next reason is that I strongly believe that coffee is one of the key beverages that will be losing in moon colonies. So, coffee water will be easily available. In addition, I added lentil water that is rich in nitrogen, phosphorus, and potassium, and are essential macronutrients for plant growth. Moreover, the starches in lentil water can promote beneficial microbes in the soil. After planting 2 pots, I exposed them to red and blue light because red and blue has the optimal wavelengths for better germination, and exposed the pots to 125 Hz radio waves in daytime and Buddhist spirit chant during the nighttime. And now it's time to grow. Okra sprouted quickly and reached over 12 centimeters in height before withering around week 6. Wing beans, however, were the stars of our experiment. They grew consistently, reaching 86.5 centimeters by the 8th week and developed up to 32 healthy leaves. We tracked the growth of every plant twice a week and noticed 3 things. First, external factors like sound and light had a noticeable impact in the early stages. Wing beans showed stronger root development and leaf growth than okra. And okra grew taller and fast, but with fewer leaves, and it withered sooner. From a sustainable perspective, both plants were promising, but wing beans were more lunar friendly. Why? Because they used water efficiently, stayed healthy longer, and produced very little waste. So, what did I learn? First, growing food on the moon is possible, but it requires creativity, observation, and persistence. The smallest factors, like the color of light or the rhythm of sound, can make a big difference. Second, okra and wing beans taught us about adaptability. Okra grew fast but faded early. Wing beans, on the other hand, stayed strong and showed great potential for lunar agriculture. In a way, this teaches us about resilience, a trait that every future space farmer will need. And lastly, I learned that science isn't just about results. It's about learning from failure, thinking outside the box, and pushing the boundaries of what we believe is possible. As someone who dreams of becoming a space scientist, this experiment gave me a glimpse into the kind of work we'll be doing on future moon bases and even Mars. One day, when humans set up a permanent home on the moon, I really hope they'll be eating wing beans, plants that we help test right here on Earth.
Our main idea was to find a simple and realistic method to grow crops on the moon by improving water retention and providing natural nutrients. Instead of changing the lunar soil itself, we focused on adding easily available materials like coir and creating a growth-friendly environment using light and sound. We aim to identify crops that are healthy, easy to maintain, and capable of surviving under lunar conditions, so future moon missions can have reliable sources of food.
you.